Hello and good evening to the NPTEL class week 2 tutorial. Uh, okay, Gayatri, if you found the assignment difficult, yes, it was slightly more difficult, yes. So it was a little more technical than the first assignment, which was more conceptual. And I think one by one, when we go through the questions, you can raise any doubts or clarifications you might require. Okay, so moving on to the assignment itself. There were 10 questions, and yeah, we'll start one by one. So the first question was for a data set of mean 21 and a standard deviation of 4. For a given value of x equals 25, what is the z-square value? It's not what is the z-square value. You need to know whether it's an outlier or not. What does one mean by an outlier? Could someone answer that? What is an outlier? What do you understand? Just in plain English, if someone could tell me what an outlier is.
I think outlier is a value that's much greater than the range of the other values in the data set. That's what
Okay.
I could understand.
Yeah, you are somewhat correct in some manner. Outlier is basically a far off value from the mean or median, something like that. It is within the range, but yeah, it's far off from all the other values in the data set. And one way to calculate that is calculating the z-square value. So I'll share my screen now. Oh, I haven't shared my screen. Okay. Yeah. So yeah, can everyone see my screen? It has the week 2 assignment and the questions on it. Could someone respond? I can't see your hands or your comments, so I need someone to speak up. Can you
Yes,
see?
yes, we can.
Okay, you can see my screen. So we just need to calculate whether this x equals 25 is an outlier or not. To do that, first you need to know. So I've switched to my PowerPoint presentation, and the first question is, oh, this is not the previous one. One second, I'll just open. Yeah. So first, to calculate an outlier, you need to know a quantity known as z-score, which is basically the value minus the mean divided by the standard deviation, the absolute value of the difference between the mean and the value, and divided by the standard deviation. That now, if this z-square is greater than 3, it means that point is an outlier. Now, given that our point is 25 and the mean is 21 and the standard deviation is 4, we get 25 minus 21 divided by 4, which equals 1, which so 1 is clearly less than 3, so it's not an outlier. So the answer to the first question is whether the given value 25 is an outlier or not. It's not an outlier. Okay, did everyone get that? Is it all okay? Does someone have any problem with that or could not understand any part of it? Please speak up.
Yeah, it's clear.
Okay. Okay, moving on to the next question. You've been given a data point which is arranged fortunately in an ascending manner, and then you need to calculate what the lower fence is. So we'll do that step by step. So you have a data set of 9 numbers, right? If you count 1 2 3 6 7 8 9. So to calculate the lower fence, you need to calculate a bunch of values. That is the first quartile, which is Q1. I'm hoping that you all are familiar with what first quartile and second quartile is. Can someone just tell me what a first and it's not a first and a third quartile is? Maybe someone in the class. What do you mean by first and the third quartile? I can't see your name, so some of you to speak up. Maybe. Oh no, I can't see your faces or names. Okay. Yeah, Tejaswini Venkatraman. Can you tell me what do you mean by first and third quartiles? Okay, I don't think Tejaswini is available. Who else is there? Syed's mic is off. I'm very sorry for that. Anantaraj, can you tell me what do you mean by first and third quartiles? Yeah, you can unmute yourself and speak. Anantaraj?
This is Sujit.
Yeah, Sujit Kumar.
So
Okay, Sujit
each
Kumar.
quartile contains what? Yeah.
Yeah.
Each each quartile contains that 25% of the population. So between first and third that quartile, that is 50% of observation will be in Q1 and Q3.
Yes, yes. So I'll just ask you one more question related to this. What is the quartile for median, for a median? I mean, which quartile is that? If you can just apply yourself. I mean, you are right. So if you just apply yourself a little more, median.
Second quartile.
Yes, it's a second quartile. So basically, it's the value at which your 50th percentage of your data point exists. Okay, like the middle value. And
Yes.
Q1 is your 25% of your data points lie before it, and Q3 is 75% of your data points lie before that value. Okay. Now to calculate the first and third quartile, these are some formulae that was straightforward. Okay, so it's basically 1 by 4 of the n plus 1th position, where n is the number of observations you have. For Q3 is 75.75 of that value. So Q1 here is 0.25. You have 9 values in the data set, so 0.25 into 10, that's 2.5. If you round it off, you get a third position, right? 3, you get 3. So third position in that data set is when you order, so you need to order it, okay? You can't like just calculate third position an unscrambled data set. You need to order it. And when you order it ascendingly, the third position is 34. Likewise, when you calculate Q3, it's 0.75 into 9 plus 1, which is basically 3 by 4 into 9 plus 1, that is 10th position. That's 7.5. 7.5 when you round it off is 8. So 8th position, that's 38 in that data set. If I can just, yeah. So that's the 8th position. So Q1 is third, 34, and Q3 is 38. And then you need to calculate something known as an interquartile range, which is basically where your 50% of your middle data points from Q1 to Q3 lie. That is Q3 minus Q1, 38 minus 34 equals 4. So this is the range from where the 25% to the 75% of your data points lie. And the lower fence is basically Q1 minus 1.5 by, into IQR, that is interquartile range, that 34 minus 1.5 into 4, which is 34 minus 6 equals 28. So this is your lower fence. These are straightforward formulae in your slides and lectures. If you are unaware of this, I would request you to look it up. It's pretty straightforward. It's just you need to apply the formula and you get it. Is this okay with everyone? Or did anyone have a problem with this? Please speak up if you had a problem. Anyone? Do you understand how I've got this value? I'm taking that silence to as a yes, that everyone's
Yes.
yes. Okay, okay, great. Moving on. Yes, did anyone have something? No? Okay, great. The next thing is, okay, this is a more of a practical data set, kind of data sets that you get, and you can get some intuitions about your data, and this is something that demonstrates that. So you've been given a data set with two variables, n, x, and y, and you're asked to show what is the relationship between them, the relationship in terms of correlation. So what do you think the answer is and why? Can someone answer that?
Negative correlation.
And why is that?
X is increasing and Y is decreasing at the same
Yes,
time.
yes. So if you can see, x on the top, it goes from 0 to 14, whereas y goes from 151 to 10. So when x increases, y is decreasing. So it's called a negative correlation. Okay. What are the maximum values? So if someone tells you, okay, correlation, what are the range of values correlations can take? I know you have not done this, but I'm just asking if someone.
-1 to 1, sir.
Yes, -1 to 1. So
-1 to
-1,
+1.
yeah, -1 will be a perfect negative correlation, and +1 is a perfect positive correlation. Okay, and 0 is, as you see it, that no
No
correlation.
correlation.
Yeah. Okay, next is kurtosis is a measure of what? Kurtosis is which moment, by the way? You have read of
Units of
moments.
data.
Can someone just tell me all the 4 moments in their order? What the first moment is, second moment is, and all that. It's just a revision of what you guys have done. So what's the first moment of any data set? So the first moment is basically the mean of a data set. Okay, it's x minus mu to the power 1 by standard deviation. Okay, later on, the second moment is the variance of the data. Third one is called the kurtosis, and kurtosis is nothing but the peakedness of data set. For example, what I mean by peakedness is this. So as your data becomes more and more peaked, your kurtosis increases. Okay, so this has a low kurtosis, a little higher, and this is very high, positive kurtosis. So, the more peaked a data is with narrower tails, for example, this has a very narrow tail but very peak or very prominent peak, so that has a high kurtosis value. It's basically the third moment. So all these moments tell you how the data set can be or looks like. Okay, is that okay with everyone? That kurtosis is basically the peakedness of your data set. Did anyone have a problem with that? Okay. Okay, great. We'll go to the next question, which is basically, okay, for a population that is normally distributed, the first and third quartiles are 1500 and 5500. What is the value of the median? Okay, can someone tell me how you arrived at the answer and what that answer is? It'll be great. Anyone? Please go ahead. Or I'll just have to call out names because no one answers. Uh, Shobha Kota. Yeah. Can you tell me what the answer is to that question as to what the median is for these quartile ranges for a normal distribution? Shobha Kota? Okay, maybe she can't use her mic. Someone else, please?
Sum of the two values, I'm taking the average of the.
Yes, it is. So so why can you do this? Why is it special for normal distributed and not for other data? Can you just explain why did you do this? The answer is
For
simple.
normal distributed data, mean is equal to median is equal to mode.
Yeah. Why is that for a normal
So
distribution? I'm trying to ask. Why do you think
because
that? For
because
example,
for normal distributed data, mean is equal to median.
yeah.
So we can apply that average principle for median as well.
Yes. That's true. And the reason for that is, for example, this middle one, this middle curve is a normally distributed data. And you'd see it's symmetric. How it looks on the left side of the mean, it looks the same on the right side as well. So because when
That's
your
an
data is symmetric, you can easily calculate the mean by just the average of the first and third quartiles, which is also the median and the mode. So the answer is because normal distributions are symmetric about their mean. Okay, which is why your mean, median, and mode are the same. And yeah, so that is for here is the average of these two values, which is basically 3500. Okay, then the next question is again a z-score. You need to do simple calculations for a distribution of with mean 50 and standard deviation 50 and a value of x equals 100. Calculate the z-score value. So what is the answer for this?
1, sir.
Yes, it's 1. How did you get that? You just basically
X minus mu by.
yeah, so you did 100, x is 100 minus mean divided by standard, both are equal. So 100 minus 50 by 50, which is equal to 1.
Standard deviations,
Yeah.
yes.
Great. After that, we have calculate the standard error of mean if ST equals 100 and N equals 100. So tell me what the formula is for calculating standard error of mean. What do you mean by standard error of mean in the first place? Tell me. Can someone tell me what do you mean by that in English? In just whatever you understood by what is represented by this value?
Standard deviation by square root of n.
Yeah, that is the formula, but I'm just asking what that is. Like, what do you
This
when
is
you see a sorry?
if your data is distributed normally, if we see the all the standard deviation of a population,
Yeah.
and that will give the standard error of a mean. Suppose we take the standard deviation of population from different sites,
Mm-hmm.
then the standard error of mean can be calculated by standard deviation divided by square root of n.
Yes.
So if from a population, if the standard deviation is taken from different samples,
Mm-hmm.
that is the standard of error of mean.
Yes. Yes. And also, what it tells you is how distributed your data is. It's another just measure of how distributed or variable your data is. So smaller the standard error of the mean, less distributed your value is. Okay. Now for
Mm-hmm.
this, it's as someone pointed out. Sorry, I don't know your name. Can you tell me your name, please? Whoever answered that, I can't see your names.
Bijan.
Debanjan. No, what is your name?
Bijan Saha.
Bijan Saha. Okay, great, Bijan Saha. So he pointed out that standard error of mean is basically SD by square root of n. SD is 100 and square root of n, that is again 100 is 10. So 100 by 10 equals 10. So yeah, the standard error of mean here is 10. Okay, great. Then for the next thing, for a distribution with mean 100, standard deviation 20 and a z-square of 4.5 corresponds to a value of what? You just need to rearrange the terms of your z-square value. For example, yeah. So z-square is x minus mean by sd. So to calculate x, if all the others are given, is basically z into sd plus mean. That is 4.5 into sd, which is 20 plus 100. That is 90 plus 100, which is equal to 190. So basically a value of 190 given a mean of 100 and SD of 20 corresponds to the z-square of 4.5. Okay. So you just need to rearrange the terms, and this is just applying the formula directly. Next, we did this last week as well. This is just a recap. How many modes does a normal uniform distribution have? Can someone tell me?
Zero.
Yes, 0. So today I've actually got an image of uniform and say normal. So here you see the uniform distribution, which is basically it's flat, right? At all given random values of a variable, the frequency is the same. This is for a uniform distribution. So there's no peak. It's a flat line. Whereas for a normal distribution, you have one mode, which is the mean itself. Like you see this. Okay. So yeah, this top thing is a uniform distribution, and that has no modes. We did this in the last class also, if someone remembers. Okay, last thing is for a normal distributed data, what is the percentage of data points that lie within 2 standard deviations? Can someone tell me?
95.
Yes. So it's basically this. So one standard deviation is 68.3, 68% of your data set. 2 standard deviations is 95 and 3 is 99.7. Remember, this is only for normally distributed data, not other kinds of data. Okay. So yeah, with that we end the assignment. Did anyone have problems with the explanation and would like to add or get something clarified? Anyone?
Yeah, I
Question
just
2.
wanted to confirm the third answer, please. I didn't hear it quite well.
Question 2, please.
Just want to confirm if it's
Okay.
negative correlation.
Yes, it's negative correlation because as x is increasing, y is decreasing. So yes, negative correlation. Maybe someone could in the next class tell me what that value of correlation is. You can plot it on Excel or something and let me know. You can try this out. Maybe I can do it for you. Let's try and open Excel and just see how it looks like. I mean, this is just because we have some time to kill. Just give me 2 minutes. Can someone tell me what the values are for each of these variables? First, for 0 it was 151, I think, and then 132. For 4 the value was, otherwise I have to just keep toggling, 108, 89, 68, 52, 31, 10. So if you plot this, you see, can everyone see how it's decreasing? Yeah.
Yeah.
So that's basically as x increases, your y is decreasing. Okay. And if you try to fit, maybe we can get an estimate of what that r value is also. There are very different ways in which you can calculate correlation, but we'll do this. So yeah, so r square is 0.9. If you take the square root of that, you get the correlation. But yeah, so that's why it's negative. And yeah, okay, that is fine. Any other doubts with any other question or anything that you found you didn't understand in what was taught?
Sir,
Yes.
please explain eighth question.
Question 8.
Yeah.
Yeah, call me Amir. Don't call me sir. Call me Amir. I'm as old as you
Sir,
guys are.
actually, I'm titled.
So for a distribution with 100 mean 100 and standard deviation 20 and a z-square value of 4.5, what value is it? So you've been
Yeah,
given
sir.
so you've been given a z-square, you have been given the value of the mean and the ST. You need to find out what x is. So x is nothing but,
Okay.
if you rearrange the terms, it's z into standard deviation plus the mean. So it's 4.5
Okay.
into 20. 20 is the standard deviation, so that's 90, and the mean is 100. So the value is 190.
Okay, sir.
You just
Okay,
need
sir.
to rearrange the terms. That's it.
Okay, sir. Thank you, sir. Thank you. Thank you.
Okay, great. Thanks.
Enough.
Welcome. Yeah. Anyone else?
Question 2.
Question 2 is okay. You've been given a data set of 9 numbers arranged in ascending order. You need to calculate what the lower fence is. Okay. So to do that, you need to just use a bunch of formulae. So you need to calculate quartiles, the first quartile and the third quartile. The first quartile is basically 0.25 into the n plus 1th position, which is 0.25 into 9 plus 1 tenth. If you do 0.25 into 10, you get a value of 2.5. You round it off, you get as 3. So third position in the data set is 34. And likewise for Q3, you get 0.75 into the 10th position, it's 7.5. If you round it off, it's the 8th position. So 8th position in the data set is 38. The interquartile range is, you need to calculate something like that, which is Q3 minus Q1, the absolute value of that. That's 38 minus 34 equals 4. and the lower fence is given by this formula, that is quartile 1 minus 1.5 into interquartile range. You just substitute the values. Our quartile 1 is 34 and the interquartile range is 4. If you substitute in this formula, you get something like this, which is 28. So the answer is 28. That okay? Did you get that?
Okay.
Yes?
Yeah, I have a doubt.
Yeah?
Actually, I got the first quartile value as 2.5.
Yeah?
I have to round it up to 3, right?
Yeah, 3.
Okay.
So
Okay.
it's become the third position, which is 34.
Okay. Okay. So if it's like less than, like supposing if not 2.5, it's less. If it's like 2.3, then I'll have to like round it up to the second position.
Yeah,
And
yeah,
if it's greater than
yeah,
0.5, like 2.8 or something,
yeah, yeah,
I have to round it up to 3, right?
yeah.
Okay. Thanks.
Yeah, welcome. So all these things you can calculate in R. I think you've just started off with R programming. It's very easy to calculate this on the computer when you code it. We'll do that sometime if it comes up in assignments. You don't even have to remember any formula for that. The computer will do it because your data sets will be really large. And yeah. Anyone else?
Sir, can you
The
please
question number
repeat
one.
question number 5? I had lost internet connection. So.
Okay. So
Yeah,
we'll do
the same
question
one.
1. We'll do question 1, someone, and then question 5. So question 1, you need to calculate whether some given point is an outlier or not. So for that, you first need to calculate a z-score, which is x minus mean divided by standard deviation. And if that z-score is greater than 3, it means it's an outlier. So the given value of x is 25 and the mean is 21 and the standard deviation is 4. Sorry, it was 4. So you'll get a z-square of 1 if you substitute this in all the values in that formula. So our value for our z-score for a value of 25 was just 1. So it's less than 3. So therefore it's not an outlier. Okay. Did you get that?
Okay, sir.
Okay. Question 5 was, we need to calculate the median for a normal distribution whose quartiles, first and third quartiles are 1500 and 5500. And to do that, you just take the mean of both values, because this you can do because normal distributions are symmetric about each other. You can do that, and when you do that, you get a value of 3500 as the median. Yeah. Anyone else? Anyone else? Okay. Any other doubts with any other questions? I will wait for some time if there are questions. Otherwise, we'll end the class. Anyone with questions? How are you finding the course in general? Do you like it? Are you finding it useful or something? Any comments regarding that? Anyone? You could just, I mean, it's okay. Hello? Okay, I think no one's responsive. You can respond, okay? If it'll be nice, because I'll feel like I'm actually teaching to someone, otherwise it becomes a problem. Okay, for now we'll just close the class if no one has anything further to say. And I think this was a great assignment, and I hope you've all done well, and if not also it's fine. You just have to learn at the end. So yeah, we'll learn together. Okay, from my side that is it for this week, and see you all next week hopefully. And goodbye, and thank you so much for attending the class. Thank you.
Thank you.
Bye.